What's up guys, I'm here and this is Whilelab YouTube channel, and here we are with day 25 of 30 days of code, and we are 4 days away of finishing this challenge and 4 days away of the end of the month. Let's go. So today's video is about running time and complexity, or the name of the challenge is running time and complexity. Alright, so what's this challenge about? First, what is a prime number? As they've described it over here, a prime number is a number that is not greater than 1 and has no positive divisors other than 1 and itself. That means 2. Okay, let's take the numbers. As you can see here in this website called the mathform.org. So as you can see, here are the first few prime numbers. You will see that 2 is a prime number, 3 is a prime number, 5, 7, 11, 13, 17, 19, 23, up to 199. Alright, so what's this about? If a number is divided by itself and 1 without remaining, only divided by itself and 1 without remaining, that means it's a prime. Okay, so if it's divided by any other number without remaining, that means it is not a prime number. Hope that's clear. So let's jump into the code. So first thing is we will get an input of the amount of numbers we are receiving. We will call this t, which is the amount of test cases, and it will pass it to the integer method and get the input. Then we will do a for loop in the range of t, and we will print, we will get the number as integer from input, and let's print number just to make sure we are doing it correctly. Let's run the code to see. Alright, so we got our numbers 12, 5 and 7, so that's good because here we have 12, 5 and 7, so we are doing it correctly. So second thing is we will create a function over here. I will call it is prime, and we will pass the number over here, or we will call an argument called number. Now the first thing we want to check is if the number is 2. Okay, because 2 is the only number, 2 is the first number if we started counting from 0. So 0 is not prime, 1 is not prime, 2 is the first prime number. So first we want to check if number is 2. If it's 2, then we will return that it is indeed prime. Then what we want to check, if you would come refer to this document, you will see here that to find a prime number, first cross out because it's not prime, so we'll cross out 1 because it's not prime, then circle 2 because it's the smallest positive even prime. Now cross out every multiple of 2, in other words cross out every second number. Okay, so now we want to check if the number is divided by 2 without remaining, or it's smaller than 2, that means it's not prime. So we'll check if number is modulo, okay, 2 equals 0, that means if it is divided by 2 without remaining, or number is less than 2, that means if it's 0 or 1, that means it's not prime. Else what we want to check now is we want to check if, okay, else for the range, okay, we'll call for j in the range of from 3 up to the number, if j modulo number equals 0, then return not prime. That means if any number between 3 and the number is divided, if any number between 3 and the number is divided by the number without remaining, that means it's not prime, because as we've said here that if it's divisible Okay, we said if it's divisible by any number other than the 1 and itself, then it's not prime. If any number came across all of those if statements and did not return anything, okay, and it did not get to the point where it executed the return keyword, that means it's a prime. So we return prime. Now, up to this moment, let's run the code. It should give us a success. Let's see. Come on. Oh yeah, forgot something. Sorry. Here, now just to call the method, we will call here print is prime, and we will pass the number. Let's run the code again. Alright, no prime. Alright, spelling error as always. This should be small. Okay, run the code again. Oh my god. Okay. So what's the problem over here? If number module j, run the code again. Okay, so if number module j equals 0, then it's not prime. Now there is a problem, there's a catch. If we submit the code, some cases will fail. And why will fail? Because of timeout. Okay, we'll see in a second over here. Okay, as you can see, test case 8 and 7 failed because your code did not execute within the time limits. And as you can see, we have some huge numbers over here. So our solution would be, if a number could be, we can find the square root of a number, and that square root we can do test cases on it, and it would represent the higher number. Okay, so if we can just here do, instead of looping up to that number, which would take us forever, for example for this code, which is about, oh my god, that number is huge, a billion. Yep, a billion. So this would have to make a billion loop. So instead of that, we would make it loop up to the point of the square root instead of the infinite number. So if we just import math over here, we can here call math.square-root and pass the number and just increase it by 1, because as we know in the range this is exclusive. So if this, for example, got 10, we would loop from 3 up to 9, and 10 is not included, so we increase it by 1, so it would loop up, so it would be 3 up to 11, and since 11 will not be included, but it would include 10. So you always increase it by, not always, just about the context, but here we will increase it by 1. So now if we submit the code again, oh yeah okay, as you can see here, the square root returns a float, but we want it to be an integer. So here we'll leave the increasing by 1 and just pass this through the integer function. Let's open the code. Congratulations, guys. So yeah, just before we finish the video, let me show you an visualization of the code over here. So here's how it would work. If I just add this, okay, edit the code. The only difference here is we are using n as a variable instead of number. Let's visualize. So as you can see here, for example, I'm passing 11, so it go next. Okay, so first thing, it would check if n equals 2, which is false, so it jump in, will not return anything yet. So we'll jump in, check if n is divided by 2 and it equals, if and remaining is 0, it's not, and n is not less than 2, so it go to the for loop. And the for loop, it will check if J, okay, so the difference here is I didn't do else statement, but still works. So here we can neglect this and make it like this, and it should still work. Alright, come on. Yeah, anyway, so here for J in 3, range of 3 up to the square root. So we will see what is the square root. So if I press next, math is not defined. Okay, we need to import math. Sorry, math. Okay, visualize the execution again. Close this. Next. Okay, so in the for loop, it would check if, as you can see, J is 3. So now it would check if in module J equals 0. I'll click next. No, it's not. Now it would check. Interesting. What's the square? Okay, sorry. What is the square root of 11? Okay, it's 3. So okay, I see. So in the range from 3 to 3, so it did one for loop, and it identified as not prime. If I edit this code and here we put this one of those huge numbers, where is it? Yeah, let's take this for example. Visualize the execution. You would find that as you can see the J here, it would get to a point where it gets into the for loop. Then it would keep increasing, as you can see on the right side here. J up to, it will not find, will it find? I don't know. Alright, then it would, okay, stopped after running 1,000 steps. So this could not even handle it with optimization. So at least HackerRank got that working. So yeah, anyway, yeah guys, thank you for watching, and that's it for this video. If you like the video, press the like button, subscribe for more videos, and see you in the next one. Peace out.